Today we are going to see the introduction to dynamic programming. Like what is the dynamic programming and how we can recognize a problem in which we are going to apply the dynamic programming. Okay? Hello everyone, this is Sharda from GoEduHub Technologies and I would like to welcome you for this session DSA with Python. Okay? Am I audible, clear and loud? Can you please tell me in the chat window so that we can start the session? Okay guys, so till now we have studied some data structures in the DSA and we have seen lots of things in the data structure. Okay, now we are going to see one of the most important topic in the data structures. Like if you are going to sit in an interview, they would be in a good company interview or good company technical round, there would be a question from the dynamic programming. Okay, so we are going to see first the concept of dynamic programming. How does the dynamic programming works? How the things will be worked in the dynamic programming. In short, we call it the DP. Okay, so what dynamic programming is about? Okay, so basically one thing comes to mind is we should remember like sub problems. We are having a problem and we are going to break the problem into sub parts and then we are going to solve the sub problems. So that thing we have done in the recursion, right? In the recursion, what we are doing? Let me tell you. It is not like you are remembering some definitions like it is the optimization, we are getting always the optimal solution. It's not like that. First we need to understand the thing is the recursion. If you know the recursion, then 50% dynamic programming you know. Because it is, you can say, it is the enhanced version of the recursion. Simply we are enhancing the recursion in some way. Okay? So the definition, you can define the dynamic programming. Let's say we are having a problem. Have you heard about the Knapsack problem? Have you heard about the longest common sequence, LCS problem? Okay? These are the certain problems. We have seen one problem is the Fibonacci series. Okay. So basically in the recursion what we are doing, we are calling again and again. We are calling a function itself. Okay. We are breaking a problem, we are having a problem and we are breaking that problem into the sub-problems. Okay? And in the sub-problems, we are solving sub-problem with the help of same function with the smaller input. Okay? Like I'm calling the Fibonacci series for the 5, then we are breaking into 4 and 3. So same function we are calling for the smaller input. So we need to break down a problem into a series of sub-problems. Okay? And one term here comes is overlapping. Overlapping, don't remember right now overlapping. I'll explain you what is the overlapping. Okay? So basically we are breaking the problem into the smaller one and then at the end we are getting the solution to merging the smaller problems and then we are getting the final solution. Okay? So dynamic programming is basically, it is optimization over the recursion. In the recursion, we are calling the same function repeatedly. But here what we need to solve like this 2 and this one. And here again you can see F3 and F2, something like this. You can see 3 I'm calculating here also, 3 f of 3 I'm calculating here also. So I'm computing one sub problem solution I'm doing many times. I don't want to do that many times. I can store the result in some place. I can store the result of f of 3 at some place. Okay? So if I'll store the result somewhere, then I can reuse that result. That is called the optimization of the recursion. Are you getting what I am trying to tell you? You can say recursion is a base for dynamic programming. You should know the recursion before going to the dynamic programming, and we have solved so many questions in the recursion. Okay? We have done so many questions in the recursion in this course. So I hope you have clear understanding of the recursion. Right? So simply we are store result of sub problems into some variables. So we don't need to recalculate. Okay? It will basically reduce our time complexity. Okay? Now we will write a simple program for Fibonacci series using the recursion. Okay? I think I have told you in that time when I taught you the recursion, but again I'll tell you one more time. Okay? So I'm taking here the example of Fibonacci series. Fibonacci series. You know what is the Fibonacci series? Everybody knows? Okay? It's 1, 1, 2, 3, 5, 8, and then you can say 13. So it is the sum of last two terms. So we will solve this with the help of the recursion first. How to write a program for the recursion? Here I am not writing the program, I am simply writing the logic. Okay? So we will write a condition for the recursion. If n is less than equals to 1, then you can say we will return, okay, and otherwise what we are doing else, we are return, this is the Fibonacci function, okay, Fibonacci of n. So we will return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Here you can see I am calling this function 2 times. Just note. Okay? And if you calculate its complexity is exponential. Okay? Its complexity is exponential. Same thing, if I'll write this program with the help of dynamic programming, you can say with the help of DP, then what I will do, like here I'm again and again recalculating some terms here. Like I'll make here the tree, like Fibonacci of 6. Okay, for Fibonacci of 6, what I will write here, Fibonacci of 5 and Fibonacci of 4. And for the Fibonacci of 5, I'll write Fibonacci of 4 and Fibonacci of 3. And here also, I'll write Fibonacci of 3 and Fibonacci of 2. Simple. Then here f of 3 f of 2, here f of 2 and f of 1. Okay, and again for this f of 2 and f of 1. You can see here how many times I am calculating f of 3 here, here and here, and there would be some more places. Yeah, in this case only the 3 places. Okay, so lots of values are being recalculated multiple times. Okay, so what we want to calculate this f of 3 only once. Okay, we don't want to recalculate the certain values again and again in sub problem. Okay, so for this what we can do, we can write this program with the help of dynamic programming. With the help of dynamic programming, what we are going to see, we are going to store this result in some variable. Let me write here, okay, and here Fibonacci, and then I'll write my program. Okay, inside this I'm write my program. So I'm storing inside the variable f result of 0, I'm storing 1, f result of 1, I'm storing 1. Then I'll write here a loop, for loop. Okay, in the for, what I will write, I'll run my loop from 2 to n. Okay, and then here I'll store f of result of I equals to f of result I minus 1 plus f of result I minus 2. Now you can see this will take the linear time, and this is taking exponential. So what we are doing here, we are only, you can say, we can call it memorization. Here we are in the memorization, we are storing some values. We are storing the values so that we don't need to calculate again and again. That's the concept of dynamic programming. And it is basically called the optimization of the program problems. You are doing memorize. Okay, so this is the basic concept, and now I can define the dynamic programming. You can say it is the enhanced version of recursive. Simple. First we are writing a recursive solution, and then we will see how we can optimize this solution. Yeah, you have studied somewhere we are making some tables and we are doing lots of things. So don't go straight, don't start making the table. In the dynamic programming, people start making the tables. It's not the way you cannot make the table directly. You are not as much intelligent, you cannot directly make a table. First, you have to understand how you can solve the problem. You have to find out either this problem can be solved with the help of dynamic programming or not. Don't write directly with the help of, don't try to write a table directly. Okay? So I think this concept should be clear to you. Now we will see how we can recognize a problem can be solved with the help of dynamic programming or not. We have to recognize either a problem is dynamic programming problem or not. How can you recognize? Okay? So for this, there should be two thumb rule. Let me write here. Okay? How to find out a problem can be solved with DP? It is a DP problem or not? We need to first find out either a problem is related to DP or not. So for this, we have to know, first we need to check out either problem have certain choices. Choices like there is certain problems in which we are finding out either this can be included in the problem or this cannot be included in the problem. Like knapsack problem. Have you heard about the knapsack problem? In the knapsack problem, we are having certain weights and we are having an array, and we need to find out either the best possible combination of problems. Like which weights we need to include to get the maximum capacity. And second thing is there should be, is there any optimal solution? Optimal solution means we are finding some max value, we are finding some min value, and we are finding some largest thing. Something like this. Like here, choices, you need to include certain things. So first we will think about, is there any recursion problem? Like we can include the recursion. We will take an example of knapsack problem. In that, we will see how we can identify either it is a dynamic programming or not. I think you are getting these two things. One is the choices problem and one is the optimal solution. Like there is some problem given to you and you have to find out some best thing from that. Like maximum fitting and minimum fitting or maximum largest possible. All these things you have to find out. Okay, we will see one thing first. We will take a problem. Okay, and then I'll tell you, we can take a list of problems, like what are the problems are included. Just a minute. What are the problems that we can solve with the help of lots of problems are there that we can solve with the help of the dynamic programming. Okay, Guys, a little bit confusion. I got a phone, so that's why I'm again starting the things. How we are finding the dynamic programming. Okay, a problem is dynamic programming problem or not. We need to find out the first thing. So for this, I'm taking certain problems. Like what are the problems basically we can solve with the help of the dynamic programming. Okay, so here I can tell you a list of certain problems. Like first thing is knapsack. Some of you already know, and if you don't know, don't worry, I'll include these things 0 1. First problem you can say, first type of problem, there are the lots of problems are based on this knapsack. And then another one is you can say unbounded knapsack. Okay, and then you can say Fibonacci, that we have seen already. Okay, certain problems are based on the Fibonacci, and then certain problems are based on the longest common sequences, and matrix chain multiplication, and dynamic programming on trees, matrix chain multiplication. Okay, and certain problems are based on dynamic programming on trees, dynamic programming on grid. All these things we can see. Okay, these are the some base problems. If you solve these 5-6 problems, you can solve 60-70 problems that are based on the dynamic programming. Like if you solve one problem of knapsack, you can solve 5-6 problems that are based on this base problem. You can say this is the parent problem. Okay, so basically lots of the problems are based on this dynamic programming. Here one thing you have heard about the tabulation. What is the tabulation? When we are studying the dynamic programming, we are always saying make a table. Okay, so basically tabulation is we are making a table, and with the help of the table, inside the table we are storing certain values. Okay, that I am not taking right now. My approach is first we will write the recursion and we understand the recursion, and then with the help of the recursion we will solve the dynamic programming. Again, I am telling you one thing, how to classify a problem as dynamic programming. So one thing is how we can recognize where we have to apply the dynamic programming. One thing is the based on the choices. We have to make certain choices in the program, either the one input is included or not. Okay, there are the some, second thing you can say, there are the some overlapping conditions, overlapping sub problems. Means one thing we are calculating again and again. And second thing is optimal solution, that I already told you. Keep into the mind these things. Okay, and steps, I can say what the steps we need to solve a program in the dynamic programming. First we will identify problem is DP problem or not. Okay, then we will decide like what the parameters we will consider. List parameters. set of parameters that identify uniquely. Parameters. Okay, we will find the parameters uniquely. We identify those parameters. You can say some states we need to find out. And then we will make a relation. Like we are making a relation, like we have to include 3 numbers. 1, 3, 5. So we will make all the combinations, different arrangements. That is called the relation. And then we will make a table. Tabulation, or you can say memorization. Okay, these are the steps we are going to do. Now we will understand one problem, 0-1 knapsack problem. What is the 0-1 knapsack problem and how we can solve the 0-1 knapsack problem. Okay. So let me take first 0-1 knapsack problem. What is this? There are the different ways to solve this problem. This problem have different approaches. Okay? Basically, first we will understand what is the problem. We are having 2 arrays. Okay? We are having 2 arrays of n items. And we need to put these n items in a knapsack. We need to put in a knapsack with capacity W. A knapsack having capacity W, and we need to put these n items into this bag so that we will get the maximum value. To get max value. You can say 2 arrays, like 2 arrays, 1 array we are having values. Okay? And 1 array we are having weights. We are having certain values, we are having certain weights. Values you can say 0 to n minus 1, n variable, n items. And weights also corresponding we are having 0 to n minus 1. And here we are given a capacity W. Okay, this knapsack we need to find out the maximum value of values so that the sum of the weights of the subset is smaller than or equal to the capacity of W. Like from these values we are including suppose 4 values. So corresponding weight, we will sum weight of these values. Again let me pick the values. Like values we are taking here 3 values. Okay, 60, 100 and 120. These 3 values I am having, and weights corresponding to 3 values. This is my V, and my W equals to weights corresponding to this is 10, 20 and 30. Okay, and this capital W is 50. Suppose my bag capacity is 50. My knapsack capacity is 50. I can fit the maximum weight is 50. So I need to make a combination. Okay, I need to make a combination of different weights so that its value is maximum. Okay, so here what the combinations I can make. Let me write here W equals to 10, 20 and 30 again, and V equals to 60, 100 and 120. These are the values I am having. And capital W I am having 50. So capacity, maximum capacity, I can put the 50. Now different combinations I will make. I can put a single item. I can put 2 items. I can put 3 items. Okay. So if I'll put only weight 10. If I'll put weight 10, then the value maximum, how much I can put the value? Corresponding to 10, value is 60. Corresponding to 20, value is 100. Corresponding to 30, value is 120. So value is 100. This is one case. Another case is weight I'm putting 20. And obviously this 10 is less than the 50. Yes. So I can put one more 20. If I'll put only the 20, then the value is for the 10 value is only not 100. For the 10 value is 60. And for the 20 value is 100. Third possible case is weight I'm putting only 30. Then value is 120. Now I'll make the combination. Obviously this 10 is less than 50, this 20 is less than 50, this 30 is less than 50. So fourth case I can make. Weight I can put 20 plus 30, 20 plus 10. That time my value is 60 plus 100. That is 160. Another possible combination is, obviously 30 is less than 50. I can put 30 plus 10. And value is 120 plus 60. Sixth case is I can put 30 plus 20. It is equal to 50. So value is 100 plus 120. Okay. And seventh case I can put 30 plus 20 plus 10. That is greater than 50. So I cannot keep this case. Out of these 6 cases, I need to find out the maximum. So maximum in which case I am getting? I am getting the maximum in the 6th case. Okay. So basically I am making all the subset of items and then I am calculating the total weight and values of all the subsets. And I'll pick only the values which are the maximum. So here 2 cases, item is included either or item is not included. Here only 10, this first item is included, 20 and 30 is not included. In the second case, the second is included, first and third is not included. So here you can see we are having certain choices. Okay. So we are picking the maximum value obtained by n minus 1 items or its weight. So we can write program for this. Simple. Yes. So we can write the program for this simple program with the help of the recursion, and then we can improve that program. Now I think you got the idea of the knapsack problem. What is the knapsack problem? And little bit idea about the dynamic programming. Why this is the example of dynamic programming? Because here are the certain choices. We can implement this with the help of the recursion. If you can implement some problem with the help of the recursion, then you can think about the dynamic program. Like somehow we can apply the dynamic programming. Okay. So I can write here the logic. You guys after the class you can implement the program. Okay. Lots of programs I have written till this class. Okay. So here I can define simple logic. My knapsack, the total capacity W and weights WT and values val, and total capacity is N. This is my simple outer function. Okay, inside this, if I'll write this function code with the help of the Python and with the help of the recursion, then I have to write the recursion termination condition. So you can say termination condition here, I'll write if either n equals to 0 means all the items are included, or my capacity is equals to 0. This capacity is like when we are capacity is 50, we have included one item that having the weight 10. So we can say remaining capacity is 50 minus 10, that is the 40. Okay, so at the end this capacity becomes 0. So when the capacity becomes 0 or all the items are included, that time we will terminate. So we can say return here. We have to write a terminating condition in the recursion always. Okay. And one condition is this, okay, and another condition is if an item having weight is greater than the total capacity, then we can avoid that item. Like if an item having weight is 60, then we cannot include this item. We need to think about all the corner cases, okay, all the bounding conditions. So knapsack capacity is 50 and our item having weight 60, then we cannot include that item. So I can write here a condition if this WT, okay, and this n is here I'm finding total number of items, suppose item is 3. So items index is obviously 0, 1 and 2. If total item is 3, here n I'm passing 3, then here I have to write n minus 1. Okay, n minus 1 is weight of n minus 1 is greater than total capacity. Then what I will write, I'll return this knapsack okay, total capacity and all the weights and all the values and then n minus 1. That item I'm eliminating. Okay, so either the item is included or not included. Now the condition when item is included, that time what I have to put? I have to pick the maximum possible condition. Return. Okay, and here I'll pick the maximum. Like all the possible conditions, maximum of value plus knapsack. Okay, so inside this I need to put value of n minus 1 plus knapsack w minus wt n minus 1. Okay, I'm subtracting from total capacity. If item is included, then its capacity, total capacity is reduced. Wt and then value and then n minus 1. This is one possible thing. Second thing is knapsack, capital W, Wt and value and then n minus 1. I need to put the maximum of this. This is the recursion. And you can see in this program, I'm calling this function 2-3 times. So one thing also you need to keep into the mind, if I'm calling a function more than once, then obviously here I can implement the dynamic programming. Okay, so we can solve this program with the help of dynamic programming. Okay, just think about it. How can you solve this program with the help of dynamic programming? This is the method one we have used, like we are solving this knapsack problem with the help of the recursion. Okay, simple recursion method we are used. And here the complexity, if you write the recursive function for this, then you can say its complexity is 2 to power n. But in the dynamic programming, what we will do, we will avoid recomputing the things. Okay, and we are putting the values inside the variable. We are storing the values somewhere. Okay, so we can write equivalent program for this knapsack with the help of dynamic programming. Okay, with the help of loop, and we are storing the value somewhere. Same thing, we are storing the value, like in the else condition I have put it the value max of this, then I can store that in somewhere. Let me write here the logic. Okay, so here I am defining knapsack W, WT and values and n. This is the thing. Now I can make a table, I can store the values inside the table. Okay? So here, or I can remember the certain things. Pawan, in the else part, I have done simple, I'm adding the value. Like if I'm including a particular item, then I'm adding its value, and from the total capacity, I'm decreasing its weight. Like in the max of this, like if it is included, there are the certain possible cases. I have written the 6 cases. So out of the 6 cases, I'm including some cases. So the cases which are providing you the maximum value. Okay? So here we are initializing a matrix. Here we are picking a matrix. You can say T matrix. And T matrix we are putting with the size n into n. Okay, n cross n T matrix we are putting. Keeping initially in the matrix we are keeping every element with the value -1, or you can put the 0, whatever you want. But we are creating a matrix. Okay, and inside this I'm writing certain conditions, like if n equals to 0, that is the same condition, or w equals to 0, then I can say return 0. Okay, that we know. And another condition I can write, if t of n of, this is n of w. I'm creating a matrix, n rows and w columns. Okay, so here t of n of w, initially I have put it -1 value in all the columns. Everywhere we have put it -1 value. Now we have to fill this matrix. Okay. So if somewhere value is not equal to -1, then what we need to do? We need to put the value, whatever we are having, T of N of W. We need to return that value. Now we are going to fill the value. How to fill the value? Okay, how to fill the value? So here the main condition is coming, how to fill the value. So filling the value, we are having this weight n-1. Element's weight is less than equals to total capacity. Okay, if weight is less than the capacity, one case is this and another else case is this weight of n-1 is greater than the total capacity. Two things we have to write. In the case weight is greater than, then we are not including that element. Just simple, try to understand the logic. I'll show you the implementation part also. Don't worry about it. Today I just want to tell you only the concept. I don't want to go in the coding part right now. Just after the class, just read out about them as maximum as possible about the dynamic programming. Because this is very, you can say very good topic. You have to solve lots of questions in this topic. Okay, so I'm just trying to tell you only the one problem, that is the knapsack problem. And this is the one way. There are the lots of ways. So one thing is two terminating condition. Two terminating conditions here I have written. Now either the item is included or not included. If its weight is less than the total capacity, then we will include the item, otherwise we won't include the item. But this time we are storing the value. Last time in the recursion we are not storing the value, here we are storing the value inside a matrix. So I can write here T of N of W. The value I am storing inside this, that is the same as the max of that I have written in the last time. Max of value of n-1 plus knapsack of, recursively we have to call, knapsack of that weight and value, okay, and total weight capacity minus weight of n-1, and this is n-1. Comma, knapsack of weight value, okay, and this capital weight and this n-1. We have to pick maximum from this, and this is we are storing somewhere. Same thing in the else part also, we are storing some value. In the else part also here, we are storing some value. Okay, in the else part, we are writing something like this, N of W equals to knapsack of WT and then value and this capital capacity and n-1. And we are returning this Tn of W here also. So basically we are storing the value inside certain variable. Same thing we have done in the Fibonacci. Okay? So in this case we don't need to recalculate the things again and again. We can use the things which are already defined. So here our time complexity is reduced. Order of n into W, it would be maximum. But if you will write this program with the help of the recursion, then your complexity is 2 to power n. You are calculating certain knapsacks in so many times. Okay, So this is the basic introduction about the dynamic programming. Basically, we are saving our time. And we are using the maximum possible things. We are using maximum capacity of a particular problem. We need to write the logic like this so that we have to avoid recalculation of certain terms. Okay guys, clear till now everything? And somebody was asking about the last 2 class assignments. Today you will get the last 2 class assignment and today's assignment also. Okay? We will publish today. You have to answer those. And right now I have certain urgent tasks, so I have to go now. So I think this is enough for today. Just study dynamic programming. What is the dynamic programming? How we can approach a question, certain questions in the dynamic programming, and just revise the recursion also, because we are using here the recursion. And if you have any question till now, you can ask me. Okay guys? Hope you are getting the concept, and this is very important topic. This is very nice topic. If you solve 5 to 10 problem, those are the base problem, then you can solve the so many problems, 60-70 problems you can solve on the basis of those problems. Like on the basis of knapsack also you can solve the 5-6 problems. So just don't remember the things, just make certain scenario how we can apply the knapsack type of problem. You can read the problem and then relate the problem with the other problems that we already studied. Okay guys? So thank you so much. This is enough for today, and we'll see you tomorrow. Okay, bye.